All right, continuing to work with the fundamental theorem of calculus, what if I were to tell you that this definite integral here is from 0 to some variable bound x of f of t dt is equal to 2 times e to the 4x power times cosine of x plus c. If I were to say that this is true here, could you find what f of 0 is and find c? So why don't you pause the video and give that a try on your own. All right. Assuming that you've given it a go, again, we see a definite integral on this left-hand side, and we see a variable bound in its upper limit. So that is a good indication that we want to use some fundamental theorem of calculus. So write out fundamental theorem of calculus, and depending on the textbook, what you're looking at, you could see this being called the first or second fundamental theorem of calculus, but we'll just leave it as fundamental theorem of calculus. And the specific version of it that we are going to be talking about is, again, when we say the following, when we say that if we were to call capital F of x and say that it's equal to this definite integral from some constant a up to some variable bound x of f of t dt, that we also need to say that f is continuous. F is continuous. That once we have this, we can say that when we take the derivative of capital F, that is equal to lowercase f of x. So that's what the fundamental theorem of calculus is saying here. And in regards to finding lowercase f of 0, well, pretty much all we need to do is just do some pattern matching. So we need to basically, let's just rewrite it like this. Let's rewrite 2e to the 4x power times cosine of x plus c, and this is equal to this definite integral from 0 to x of f of t dt. And now, remember, under our notation here, this is capital F of x. This is capital F of x. And if we want lowercase f, well, then we just need to take the derivative of this. So let's take the derivative of capital F of x, and we get the following. So we're going to use some product and chain rule here. So we're going to have 2e to the 4x power, and we need to use some chain rule here. So derivative of 4x is going to be 4, and then we keep cosine of x, and then continuing to use the product rule, we have 2e to the 4x power. Derivative of cosine is negative sine of x, and there's our derivative. And again, we set up here under this fundamental theorem of calculus that our derivative of this capital F function here is equal to lowercase f of x. And we ultimately want to find what f of 0 is. So we have f of x now is equal to this whole thing. We can just rewrite it. So we have 8e to the 4x times cosine of x. And then we have minus 2e to the 4x power times sine of x. All right, and then what do we want to do? We want to find f of 0. So let's just evaluate this function that we found at 0 and see what we get. So we have f of 0 is equal to 8 times e to the 0 power cosine of 0 minus 2e to the 0 power times sine of 0. And what does this evaluate out to? Let's see. We have this second term here, sine of 0 is just 0. So this whole term is going to go to 0. And we're left with 8 times 1 times 1. So this is 8. F of 0 we found to be 8. So that's the first part of our problem right here. F of 0 is 8. So we found f of 0, and now we need to find what c is. And how do we find c? Well, really what we're going to do is use some of our notation from earlier and apply an integral property, a definite integral property. So we're going to pull up our notation from earlier. We're going to say that we called this f of x. F of x is equal to this definite integral here with a variable bound. So we have capital F of x, all right, is equal to this definite integral here from 0 to x of f of t dt. Okay, and then what happens when we evaluate capital F at 0? Well, this definite integral becomes 0 to 0 of f of t. Let's make that a little neater. Of f of t dt. And again, any integral here with bounds from 0 to 0, we have that's just 0. So we find that f of 0 is 0. Now, under that, we can then, again, use our notation. We called that f of x is equal to 2e to the 4x power times cosine of x plus c. So let's now write that out. So we have f of x is equal to 2e to the 4x power times cosine of x plus c. And now what happens when we evaluate this at 0? So we have capital F of 0 now is equal to 2e to the 0 power times cosine of 0 plus c. And we said that f of 0 is 0. And then on this right-hand side, we have 2 times 1 times 1, so we have 2 plus c. And then finding c, we have c is equal to negative 2. C is equal to negative 2. And that is the problem. And what you can see is, okay, we just used the fundamental theorem of calculus. It did some pattern matching pretty much. And then to find c, all we did was use a definite integral property. So really this problem is just asking, okay, do you know what's going on with the fundamental theorem of calculus? And can you do another version of a problem that maybe you haven't seen before? But really it's just talking about the fundamental theorem of calculus and a definite integral property.